Have you ever wondered what a banana sees on its way to the US? Well, besides the inside of the cargo container. It went on a whole journey and met up with all the rest of those cargo containers and all the things inside them. Like a bunch of crates of grapefruits. But how'd they get to the same port as this banana? And where did they go after? On its way to the US, that banana followed so many different routes that crisscrossed the globe in fascinating ways. And it isn't just the routes that are interesting to geographers, but what moves along those routes and who can access those goods, even the vehicles that do the moving. Even the parts and pieces of cars and trucks tell a story of industrialization and globalization, and have geographies all their own. I'm Alize Carrere, and this is Crash Course Geography. Today, the movement of people and ideas is part of transportation geography, where we build models and study how to optimize routes and networks. And transportation planning puts all that theory into practice. Transportation planners design optimal transportation networks to most effectively move goods, information, and people from one place to another, from shipping routes to airplane traffic, and even the internet. But to get stuff from one place to another, we also need things to actually do the moving. And that's helped create entirely new areas of research in geography and other fields. Like with the invention of assembly line production, parts to cars were mass-produced and whole new landscapes developed to support that industry. And as the landscapes changed to reflect these factories and new production methods, industrial geography emerged. And as industrial geographers, we try to understand how different industrial spaces grew in the past and how those locations will change in the future. Take, for example, the first automotive landscapes that formed across the manufacturing belt of the upper Midwest of the United States. This region overlapped with coal and iron mining, and that wasn't a coincidence. To see why, we have to go back to the early 20th century when Alfred Weber, a German economist and geographer, developed what's often translated as the least cost theory to help industries figure out the locations that will help them keep operating costs the lowest. Least cost theory uses 3 points to triangulate a location. The cost of labor, so like the wages for people who work in the factory, the opportunity for agglomeration, so like stores pooling together to form malls with shared parking lots, food courts, and public spaces, and the cost of transportation, so how much it costs to bring the raw materials to the factory and to ship out the finished product. Each leg is pulling on the center of the triangle, and where there's the smallest cost to the factory owners is the ideal place for industries to locate. Because Weber was thinking about this during the heavy industrial revolution, the transportation corner of the triangle was the most important to him for this theory. And to optimize transportation costs, it's all about the weight of the cargo, because heavy stuff costs more to send. So the ideal situation is for the stuff that has to travel the longest to be the lightest. For car making, that means some of the biggest transportation costs come from moving heavy raw materials, like the iron ore, and then steel that go into the body of the car. But in the upper Midwestern US, there are lots of iron deposits, and so also iron mines. And the steel industry was pulled to this region for similar reasons as a lot of the automotive industry. Iron ore and the steel it creates are heavy, so it benefits all three industries to be nearby and be able to use the lakes and other waterways to move their products between cities. In general, the transportation corner of least cost theory breaks industries up into two categories. Bulk or weight-reducing processes lose weight during the production process, so they're more likely to locate near the raw materials, like processing food close to farms or processing lumber close to forestry operations to minimize transportation costs. But bulk or weight-gaining processes gain weight during production, so they're more likely to locate near where the finished products are sold to minimize transportation costs. Like beer or soda bottling facilities are often just outside major cities because the ingredients weigh less than pallets upon pallets of full bottles. But transportation costs make up just one corner of the triangle. Agglomeration is also part of why the steel and automotive industry set up shop in the Midwestern United States. First, it was easier for the steel mills to locate where coal and iron could easily come together. Later, the automotive industry also located near steel mills, so they could more easily take advantage of all the people already trained in manufacturing, and to take advantage of services like lawyers who specialized in manufacturing and labor law. And because of the agglomeration of rail, highway, and shipping hubs in the manufacturing belt, especially around Detroit, Toledo, and Chicago, the automotive industry could be a weight-reducing process. The lighter finished product could move across the country or around the world, taking advantage of the shipping infrastructure around the Great Lakes, the interstates, and abundant rail lines. And finally, both the agglomeration and transportation corners were influenced by the cost of labor. In the Midwestern US, there were lots of people needing jobs, like farmhands looking for work in the city, or immigrants looking for a better life. Altogether, transportation, agglomeration, and labor have been used to explain the rise of car factories and steel factories from Pittsburgh to Chicago in the 19th and 20th centuries. And geographers and planners have used these spatial draws to influence the location of industries ever since. But whether it's steel or cars, or banana cars, most industries are trying to maximize profit. So to do that in least cost theory, they're also trying to keep costs low so that the money made from the sale of goods will be profit rather than covering costs. And to do that, over time we've come up with other techniques and theories to manage costs, like taking advantage of highly efficient transportation routes so that just-in-time production, which originated in Japan, became standard throughout the automotive industry. Just-in-time production is a model for how to structure a supply chain, or the network that moves raw goods from the source through manufacturing to the final consumer. Just-in-time production tightly integrates how much people are buying something with transportation efficiency. The products are only manufactured as they're ordered and then shipped quickly. In this model, there are much lower agglomeration costs because different parts tend to develop close to each other. And being so close, they can share knowledgeable labor and move pieces of the car from manufacturing to completion, like a well-choreographed dance number. But if any part of the supply chain is disrupted, all production stops. So whether it's the new manufacturing landscape created by just-in-time production or the historic manufacturing belt in the Midwest USA, the connections across suppliers and manufacturers create a functional region, or a region that's held together because of connections between nodes. Central cities like Chicago were focal points for supply chain nodes between mines in Appalachia, factories around the Great Lakes, and shipping routes. And the boundary of this region is where a focus point shifts to create another center with different economic, social, and political interests, like Los Angeles. Though by the 20th century, ideas and legs of the least cost theory no longer seem to be holding. So what economists and geographers call the substitution principle developed as a modification to the least cost theory. It says that if the cost of one or more components from least cost theory dramatically declines, then that allows the costs of another component to increase. And that seems to be what happened to the automotive industry. Throughout the late 20th century, transportation costs started to decline because of innovations and low fuel costs. At the same time, new global trade agreements made it easier to import goods like cars and car parts from countries with lower costs of living, and therefore lower wage demands. And even the materials like steel started being produced in other places, again for lower cost. Essentially, it might cost a little bit more to ship something from outside the US, but the labor costs are so much lower that it's still worthwhile. We've just covered like 40 or 50 years worth of developments in a few seconds. But ultimately, US-based industries moved their factories to wherever that least cost arrangement found a sweet spot. Soon, raw materials came from places like Japan and Malaysia, were processed in factories in places like Mexico, and shipped to the US to be sold, thanks to globalization, which is when different sectors of the economy and economic activity interact and crisscross around the world. And because of how far and wide goods could move, tons of multinational corporations rose up in the late 20th century, creating corporations that do business across so many borders that they only loosely belong in one country or another. And this has implications for how we think as geographers. Like geographer David Harvey famously explained that by moving around the globe to seek out the least costs and highest profits, there's a friction between space and time. Basically, the cost to transport something has become so small that we no longer think about how far something has to travel as a cost to be avoided. We travel around the world in hours. Or heck, I could order a tiny hammock for my pet rats and have it arrive today if I wanted to. Faster and faster shipping and travel have compressed or annihilated space. And so we think about space differently now. If it can travel fast enough, the distance doesn't really matter, right? This makes these functional regions look really messy and very globally connected. In response, the industrialization process has shifted as supply chains go through de-agglomeration, which is when supply chains are broken up and the pieces are moved to completely new places and configurations. Though economic geographers have noted that as de-agglomeration happens, eventually new economic situations form. It can take a painfully long time for the unemployed to find new jobs, and any new jobs in the region may not employ the same people as those who lost jobs to the movement of industry. For instance, the industries that spring up may require workers with a totally different skill set, and this has led to outsourcing, or contracting with foreign third parties rather than manufacturing parts directly. And these big multinational corporations put pressure on the unity of a state, because multiple countries are involved with sometimes competing interests. Now, supply chains and labor are often in different countries with different rules. And governments can try to create tax and tariff rules to nudge corporate costs to be advantageous for their locations. There are a lot of things to balance, and this constant change is unsettling. Laborers around the world regularly protest at World Trade Organization meetings as regions wrestle with uneven economic opportunity within and between countries. And there are tensions within countries to resist global trade networks that open up low-cost labor. Future industrial locations will certainly keep shifting as new innovations and situations change the equation that calculates what's most expensive to an industry. Like as energy costs change, we might see locations shift based on how affordable energy is. Or as there are changes in transportation technology, like high-speed rail systems and smart roads and smart cars, geographers will keep studying and predicting how they'll change the spatial organization of industrial location. Ultimately, the push and pull of global economic dynamics end up having very particular local outcomes that can both be harmful and create opportunities. Like as old industries move out, new ones can move in, which we'll talk about more next time when we look at sustainable development and environmental planning. Many maps and borders represent modern geopolitical divisions that have often been decided without the consultation, permission, or recognition of the land's original inhabitants. Many geographical place names also don't reflect the indigenous or aboriginal peoples' languages. So we at Crash Course want to acknowledge these people's traditional and ongoing relationship with that land and all the physical and human geographical elements of it. We encourage you to learn about the history of the place you call home through resources like nativeland.ca and by engaging with your local indigenous and aboriginal nations through the websites and resources they provide.